Hello, everyone. My name is Howard. The presentation today was done by my student, and I just present their results. So the main idea of this research was we want to see if we can swap the algorithm for the LSPIV to improve the accuracy of LSPIV. So I think you have already learned a lot from Fujita and Alex, say something about the LSPIV, and I hope this information is correct, because I learned that this method, actually the Fujita is the father of this LSPIV, and it was roots from the PIV method. And when you use this method, there are kind of two main difficulty when you try to get your surface velocity correctly. The one is the auto rectification based on your ground reference point. If you cannot have a good ground reference point, then when you correct your image with a very bad angle, then your raw data will be kind of skewed, so you cannot get your result correctly. Another point which will affect your result is when you're using the algorithm to calculate the surface velocity, you have to use the cross correlation method, and there are a lot of parameters you have to set. I think Alex has mentioned that yesterday. You have to define the interrogation area and searching area. And if your raw image was affected by a lot of noise, then those factors might affect your result. So our research is try to see if there are another algorithm which can swap this cross correlation method, and which is not that sensitive to those parameters. So because this idea was root from the PIV, so actually in the lab, it's easy to have a good raw image. But in the field, there are a lot of noise which will affect your image. For example, the picture angle, and the wing, and the shadow, and a lot of things, a lot of environment will affect your raw image. So if you cannot have a good raw image, you will get the wrong data or the less accurate result. So we try to apply the CNN method to see if we can have a better result to avoid to avoid the environmental noise effect. The idea of CNN is actually the CNN method, they extract the sub image characteristic. It's not exactly using the image intensity to do the comparison. So we apply this algorithm to do the surface velocity measurement. As you can see, the only thing we do is, instead of using the cross correlation method, we swap the CNN method into LSPIV. The rest of the procedure are the same. So we only change the algorithm to calculate the surface velocity.
Howard, can I just interrupt you briefly? Could you turn presenter view off, please, in your version of PowerPoint? We can see your notes and the screen preview ahead of time.
Oh, okay. Sorry. I think I have to, how to do that.
Yeah, or swap screens. Howard, if you have two screens, I usually make this mistake, which is why I always ask the audience if they can see it properly.
I have two screens, but I don't know how to.
Yeah,
let me see if I can do that.
There's usually an icon that shows the sort of it's swapping from one screen to the other.
Let me stop the share screen. And let me see, I'll drag this, and see if I can do the share screen correctly. Is it correct right now?
We're not seeing it just now.
You don't see anything?
No, I don't at the present.
Oops.
It's just loading now.
It's the same. I don't know how to.
Okay, so if you go back to your talk.
Go back to my talk.
Yes, your presentation. And then at the bottom of the screen, so if you load it up into like you're presenting.
Let me see.
Alternatively, at the very top of the screen, there's a thing called, in mine, in English, it says display settings. There's a picture of a little screen, and it says swap presenter view and slideshow.
So
yeah, I was going to point you towards the circle to the bottom left-hand corner and the 3 dots. There you go. That seems to have...
Yeah, that's good.
I finally figured out how to do that. It's very difficult for me. Sorry, this is my first time using the Zoom to do the presentation because Zoom was kind of banned in Taiwan. We are not allowed to use Zoom to do the meeting. We have to use different software. Okay. Anyway, so the idea is we want to test if the CNN can do better than the cross correlation. So we do a lot of the model to see which one is the better. Anyway, we have different layer of the convolution layer and do the a different setting of the pooling. So anyway, this is the final model which we apply to swap the direct cross correlation method. And the interrogation area, we found that CNN is not that sensitive to the interrogation area. But still, the 64 by 64 might be the best setting to do the simulation. And we know when we do the cross correlation, you will create this this matrix, and then you have to do the sub pixel precision to make your result more correctly. But when you're using the CNN will create this kind of the loss matrix, which is not like the matrix which you have received from the cross correlation method. So if you apply the original subpixel precision method like Gaussian, you cannot apply this to the CNN this loss matrix. So we use different way to do the subpixel fixed adaptation, which is we use how to say. The first thing is we So we subtract the one subpixel images, and then we compare to see if the matrix subpixel images they didn't shift. So we compare these two and see if the shifting is we can see a little bit shifting, and then we collect all the subpixel shifting and then do the average. So anyway, so we use this method to do the subpixel precision, and the comparison is we use the vector correlation coefficient way to do the comparison, because the result obtained from the cross correlation method is the 2D vector, and CNN also get the 2D vector. So if you want to compare these two, you have to do the vector comparison. So we use this method to do the comparison. And the discharge estimation is pretty much the same like the original PIV, LSPIV method. So we use the PIV lab, the software, to create the artificial images. So we know the right answer, which we call it the benchmark answer. And then we apply the CNN method and the DCC method to see which one can get the best, can get a better result. Okay. So if the images, if they are clean, as you can see, sorry. So we also use the clean image and the blur image because we want to prove the CNN is less sensitive to the noise. So we create the clean image and blur image and see if the CNN can do better. Also, we also test our method in the flume. The flume was also measured by the ADV. So if you have ADV result, then ADV result can be the benchmark to compare those two methods. So I'll jump to the result directly. So as you can see, if images are clean, the CNN method and DCC method can get the similar result. However, if you have the image with the noise, the CNN method can still have a good result. However, the DCC method, the result will be a decrease, okay? And the same case, if you have different noise, like if your particle is larger or smaller, or if the particle, the density is less, or the particle density is more, no matter what, the CNN is pretty robust. They can get the pretty much similar result to the correct answer. However, DCC will be affected by the image quality, okay? So if we have more noise, as you can see, if the noise increase, the DCC result will decrease very fast. However, the CNN still get the good result. Even if we use different flow pattern, the one on the top is the vortex, the one on the down is the jet. If you use the jet, as you can see, if you have increased the noise to like 35%, the CNN can still give you a good estimation for the velocity. However, the DCC decreased the result very quickly. And if we compare to the flume measurement, and then we can see the measurement obtained from the DCC has much more outlier. However, with the CNN method, no matter what kind of the image you give it to the CNN, the CNN can have a less scattering. So which means the CNN method is more robust compared to the cross correlation method. If we compare in the flume, compare our result to the ADV, as you can see, the CNN and DCC can also get a good estimation with the discharge. So my conclusion is we have already proved the CNN is more robust because it's less sensitive to the noise. And another thing is the CNN is less sensitive to the setting of the interrogation area. And this method can be, in the future, I think can be applied to the environment because in the field, the raw image, you might have a lot of noise. So if you use the cross correlation method, then the user has to be very experienced to clean the noise, or you have to use the great setting of the interrogation area or searching area to get accurate results. However, if you use the CNN method, then you don't have to, you don't have to. If you use the CNN method, the setting can be pretty much the same, but still give you the accurate answer. Okay. So this is the presentation today. Sorry that I'm not very good in the using this Zoom to do the presentation.
It's fine. It's not a problem. Thanks for that, Howard. We have a couple of minutes for questions. So I'd like to open the floor for questions, particularly to our software developers, see what they think about these findings.
I have one question.
Yep.
Maybe two. Thank you for this interesting work. My first question, maybe I missed that in the presentation, but would be to know if you, in the training set for the convolutional neural network, if you used also images with noise. This is the first question. And then the second question is on the projection of this to field scale, where the noise might be much more complex, and then having training data sets with reference data might be also really challenging to sample the variability of flows and environmental conditions.
Okay. Well, actually, when we do the training, we use the clear image and also the noise image to do the training. So the drawback to use this CNN method is time consuming, because you have to have a very good hardware to do the training, and it's take time. But the thing is, if your result is not the real, you don't care about the real-time result, and using the CNN method can be, I think can be robust to continuously give you the accurate and accurate answer. And also, as you mentioned that in the field, if you do the LSPIV measurement in the field, you might have a lot of noise. So actually, right now my students are trying to apply this method in the field. So we took a lot of the continuous image from the drone, and even in the raining day and windy day, and we want to see if the CNN can get a good result too.
Okay. Thanks for the clarification. I'm very curious about the results obtained for some kind of noise that was not learned from the training set. Thank you.
We have a couple of other questions that have gone into the chat. The first one is about the training of the CNN network. So it's how many images did you use to train your CNN network? And then the second one is there a difference in the computational time between DCC and CNN?
Let me see if I can. Well, in this case, the training image which we use is around like 10,000 images, and the computational time, the hardware, the image card we use is RTX 1080i. So the computational time is hours. So if you compare to the cross correlation, it only took like minutes, 10 minutes or 20 minutes, and you can get the good result. But with our machine, with our computer, it might take like 3 to 5 hours to get the same result. Mm-hmm.